Today, I'm spending 24 hours investigating NASA's robot factory, where they build devices that do what people can't in space. From a drone on Saturn's moon Titan to a telescope that will finally answer the question of what is dark matter, these devices are going to help us finally know whether aliens are real or not. And in order to see this stuff, I have to get gowned up.
So you want to get a hairnet, which is right behind you.
Okay.
Put it on your hair, cover your hair. Then you want to put a mask over your face. You're protecting the devices from whatever might come out of your nose and whatever might come out of your mouth. You should sign in. You want to grab some gloves. You want a hood and you want a coverall. So now you can see we've got that extra layer of protection. So if you wanted to follow us in.
You're the first person ever to film the clip, just so you know.
So this is the Micro Devices Lab, which can enable NASA missions, new NASA space telescopes.
So this lab is kind of like the computer engineers for NASA, but instead of making products, it's tiny singular pieces of space computer hardware.
We utilize the same kinds of machines that Intel utilizes to make their chips, but we're specially purposed to make these micro devices that help see farther, fainter, measure things, look for life, those kind of things.
But sometimes, by accident, this lab ends up inventing stuff that could benefit products on Earth.
The camera that you're using there, it's a CMOS camera.
Yeah.
The chip inside there, actually a lot of the foundational work to develop and mature that chip was done here in this building by our colleague Eric Fossum back in the early 90s. The original concept was, can we make a lightweight sensor for planetary exploration that could go out on a spacecraft? This now has turned into something which everybody has in their cell phone. There's 8 billion devices a year or something like that.
But they're also developing a really cool system to communicate between planets.
We would like to be able to get that same amount of data that you're seeing right now in this YouTube video back from interplanetary space. But we can't run a fiber optic cable out to interplanetary space. We need to have a telescope, and you need to beam the light in free space back to the Earth. So we just used these superconducting detectors in NASA's first demonstration of free space laser communication from interplanetary space. We got 267 megabits per second from Mars.
And that's crazy, because that's coming from another planet, and my home's Wi-Fi isn't even that fast.
People take a lot of this stuff for granted, you know? They see, like, in movies, like, people are able to FaceTime basically back down on Earth, and it's like people just forget everything's different when you go to space. It's not like you can use any of the infrastructure that has been built over the last few centuries here on Earth. And so there's so many things that people just take for granted, I think, about being in space, that like you have to build from scratch because there's nothing there.
Other than the stuff we put there. And we're about to put something really cool there called the Nancy Grace Roman Space Telescope, with a very special type of lens on it.
You have one instrument that is called a coronagraph. It's something that will look at the sky and will help us try to detect exoplanets. Most of those planets are orbiting around their own sun, and the sun is extremely bright.
And the problem with that is that sun's brightness will block out the planet from being seen.
You put your hand like this to opaque the sun. We do that with technology. The path at the center would be where the shiniest star is, and we opaque this.
And by covering the star in this very specific way, they're able to view exoplanets much better. But let's view the telescope itself, which was all the way in Washington, D.C., at NASA's other robot factory, the Goddard Space Center. So I flew there to see it. But step one was learning a little more about this secret government gravity detector telescope they'll be launching soon, like how careful we have to be with it.
This is cleaner than an operating room.
So I asked my first question. My question is dark matter, dark energy. Obviously, that's, you know, sort of one of the major things that this is going to help us learn about. What sort of hypotheses do we have right now, and what sort of questions do you think will actually be answered?
The universe itself doesn't behave the way people expect it to be behaving. What we're finding based on measurements taken both on the ground and with our space-based telescopes is that the universe is in fact expanding, and the rate at which it's expanding is accelerating. That means there's got to be something else in the universe. There's got to be more mass in the universe. There's got to be more energy in the universe. Hence the terms dark energy, dark mass. With the speed at which the Roman Space Telescope can move, we can scan the sky 1,000 times faster than our existing telescopes. And by starting to look at how that universe behaves, we can start to infer what all the stuff is that we can't see, because we see its influence on the universe in a way that we've never been able to see before.
But he never actually answered my question on what they think it is. So I'm gonna have to investigate myself. But first, they led us to the back rooms to show us some other secret facilities they have.
This is the acoustic testing facility.
So this is the room where they blast spacecrafts with ballistic amounts of sound to make sure they can survive the noise of a rocket launch.
And it's like the kind of sound that would again, kill you. That's why those doors are so large.
And then we kept walking to meet the team in charge of exploring Titan. Titan is Saturn's largest moon, one of 292 moons it has, in fact. And even crazier, we discovered 128 of Saturn's moons in March of 2025. So depending on when you're watching this, we may know of even more. Even though there may only be 8 planets, most people don't realize that the moons of these giant planets in our solar system are practically Earth-sized. And so we should explore them and treat them as planets, especially because Titan is the most Earth-like body in our solar system, with lakes and potentially alien life. But before we send humans, scientists are sending a really advanced drone.
We're sending like a large rotorcraft. This is like a 10th scale model. This one is actually like the size of a car.
While we learn about this drone, let me tell you about Coddy.
We're gonna get samples, drill samples from the surface, which is something we've done on Mars.
Because even though we have AI now, understanding how to code and knowing what you're seeing is obviously crucial if you actually want to build software. Coding is a language, and using Coddy, you can learn that language, just like you would with Duolingo.
We're gonna ingest those samples. They're gonna go into one of the cups in this carousel. And that's how we get, ultimately, what types of molecules are there on the surface of Titan. You know, we expect to find a lot of organic molecules. Organic molecules, that's what we're all made out of.
Which is really cool. Almost as cool as how when you download Coddy, you tell them exactly where you're at with coding, and they'll meet you there and take you to the next level. It's a fun, gamified experience for anyone from complete beginners to aspiring developers looking to improve their coding skills.
Ultimately, we want to try and provide some new answers to the question of how did life arise? That's a really big question. We're not going to answer it all by going to Titan, but going backwards in time on Earth, we can only go so far. Maybe the microbes in the rock record, but that's really stretching it. We want to understand the chemistry that led to those first cellular life forms here on the Earth, and therefore how likely it is for that kind of chemistry to happen elsewhere in the universe.
Yeah.
It's really hard to look here.
Coddy is free and creates a daily habit of you practicing code. And their AI tutor gives instant feedback, so you'll never get stuck. How do the flying conditions on Titan compare to Earth?
The atmosphere is 4 times the density.
What's the gravity like on Titan? And how
It's
does
a
that
seventh.
affect building a drone? Oh,
Yeah.
great.
It's a seventh of what we
Exactly.
experience
So you
here on
got
Earth.
denser air, so it's easier to push, right?
And less gravity.
Less gravity. So
Win-win.
yeah.
I love it.
And if you love the concept of Coddy as much as I do, check it out at the link in the description. Clicking these links really supports me, so thank you guys. But there was still one more robot NASA wanted to show me today, and this one does something I never thought about.
Hi, David McCall. We're going to show you LEVS, which is a lunar environment learning station, be making continuous long-term observations on the seismic activity on the moon.
At first I didn't understand why we needed to learn about this, but then I realized it was for the safety of future moon crews.
I don't know why I never thought about if there would be earthquakes on the moon. Probably because it's not an earthquake, it's a moonquake. But that makes so much sense. Now I understand why we have to learn more about the moon. If we want to have people there permanently, then we have to know if it's dangerous, if there's bad things that could happen to them, like the moon shaking and then them falling over and dying.
While we're here with this very high-level NASA scientist, I figured I'd ask some questions that are on my mind.
I have a question.
Yeah.
So I'm like a space science YouTuber, and I get a lot of really fun comments. People are very, excited, and they have these big dreams and stuff like that for space. I'm curious for you as a NASA scientist, you have your specialty in seismology and your projects and whatever. How often are you thinking about our place in the universe and all of that sort of stuff? Or is it more almost just efficient to just think about the nitty-gritty on the day-to-day?
For me personally, I think keeping the big picture in mind is the ultimate motivator, and I relish the opportunities I have to take it back to the big picture, and that really helps me stay motivated. So thinking about my place in the universe isn't necessarily part of my day-to-day job, but thinking about the big picture definitely helps keep me inspired and keep me motivated.
And the reason I asked her this is because all these people, the smartest brains humanity has to offer, are here together, just trying to answer those big picture questions about us. And although I'm nowhere near smart enough to join them on that endeavor, I love being able to show what they learn about space to you. And that's what this whole channel is about. So if you want to join that journey, subscribe.